Good evening, everyone, and welcome to another episode of Focus Astronomy's Star Stream. Now, if you're just joining us for the first time, I'd like to personally welcome you. My name is Kevin Legore. I will be your astronomer and telescope operator for the evening. And tonight we're going to be checking out galaxies. And we've got a ton of stuff to actually check out this evening. So we're going to be kind of busy throughout the night. If you're new to joining us, or if you've never heard about Focus Astronomy before, Focus is a volunteer outreach program for astronomy based out in Phoenix, Arizona. We see about 30,000 people a year, and we try to provide free interactive astronomy events for schools and the public. And in light of our current situation, not being able to host our events in person, we are doing our live virtual star parties right here online, and we do that every 2 weeks, so every other Friday at 8:30 p.m. Pacific time. For our summer ones that are coming up, they're going to start at 8:30 because it just doesn't get dark until then. So without further ado, we're going to get started. But before we get diving into the telescopes this evening, just to give you kind of a rundown of what we're working with tonight, and then we'll be getting into the telescope. So let's check this out real quick. So if you're just joining us, we have a range of equipment that we use for our Star Party events and our virtual events. And tonight we needed something with a little bit longer focal length. So tonight's equipment list for any of our astronomers or our techies in the audience, this is what we're using this evening. This is a Skywatcher EvoStar 150 millimeter ED APO refractor. And we have a reducer, which actually allows the telescope to have a wider field of view a little bit. So that's running at a focal length of 1020 millimeters this evening. Our camera tonight is a Starlight Express Trius 694. It's a monochrome black and white camera. It's allow us to get a lot of sensitivity out of what we're looking for. Because we are shooting in an urban environment, we need to get rid of some of the light pollution. We're using a filter from the company Coma, and this is their low glow filter, so it knocks out some of that light glow in there. And then we have our setup on a software bisque Paramount MX, and wrapping that up with the Starzona microtouch focuser is on board to control all of that. And that's what we're going to be using this evening. So just to give you an idea, tonight is all about galaxies. And before we jump into the actual imaging portion, let's just get a feel of what we are actually going to be viewing tonight. I understand some people are new to astronomy that are joining us, so we'll go kind of do a basic overview of it right now. So we are in the Milky Way galaxy, and the closest galaxy that looks like our own is the Andromeda Galaxy, what you see here. This was shot off of one of our smaller telescopes. A 3-inch telescope took this. And this is a spiral galaxy, and you can see right in here you have all the spiral arms and the dust bands, and our Milky Way looks very, very similar to that. And if we were to see where we reside in the galaxy, we can pop ourselves right there. Roughly that little yellow ball right there, on average, would be right about where our solar system sits in the Milky Way. Now, if you've ever been to a dark sky site away from city lights, the night sky looks very different than what we would normally see. And it would look something like this. And this is our own Milky Way galaxy. We have the core right here, and the arms moving up to the vertical portion of the sky. Now, this edge right here, imagine you're looking at the edge of a CD or down a pancake. This is what we like to call the Galactic Plane. That's what we're looking down at this point. So let's rotate this to make it a little bit easier. And now we've leveled out the Galactic Plane. to make it look more as it would be if we're looking at it edge on like a CD. So looking at this further, we need to see the whole galaxy at this point. So I don't have any fancy graphics, unfortunately, for that. So we're just going to resort to our imaginary galaxy right here. This is our Milky Way. And imagine you're looking at the edge of a CD and you get the galactic plane as you look along the edge of the actual galaxy. And to put us in reference of where we are, we would be on about a little ways out from the core, or the center, is where our solar system would be. Now, this time of year, and what we're going to be looking at tonight, are all galaxies. And the galaxies that we're looking at in the region of the sky that we'll be spending most of the time in is actually off the plane of the galaxy. So we are actually going to be looking off the actual galactic plane. And this is the region of the sky that we're going to be looking at tonight. And we're going to be working in the constellations of Leo, Virgo, Coma, Berenices, and several others. And I can point that out here in a second. But that was just kind of a little basic overview of ultimately what we're going to be working with tonight, and just a basic understanding of galaxies. So that pretty much shows us what we're going to be doing this evening. So we're going to jump over to the telescope now, and we have over a dozen objects on the observing list this evening, so we're going to be quite busy at the moment. So let's get started there. And let me bring up our telescope system. All right, so this is our telescope control software. This is SkyX is the name of the software. It's made by a company called Software Bisque. And this is controlling our entire telescope system this evening, anything we want to look at. So to start things off, there are actually two comets in the sky tonight, and one of them has been in the news for quite some time, and that is Comet C 2019 Y4 Atlas. That is a bright comet that's actually been visible in the nighttime sky the last couple weeks. Unfortunately, it was supposed to get rather bright, but the sun had its way with it, and now it's actually broken apart. There's not a lot that we can... It was supposed to almost be naked eye visible as we moved into the summer, but at the moment, because it's starting to break apart, it is becoming very difficult to actually see, and it's getting rather low. It's in the constellation of Perseus, I believe. And we're gonna give that a shot and see what we can actually capture on this comet. So it's, like I said, it's pretty low, so I don't know if we're gonna be able to get a view of it or not, but let's give that a shot. So this evening, when we're doing astronomy, we're actually taking long exposures of distant objects. So instead of going click with a camera, that's actually open for an extended period of time. So some of these exposures are going to be 10 to 15 seconds. Oh, it's actually visible. It's a little difficult to see because it's getting rather diffuse. But let me just show you guys where we are working in right now. Right in the middle here, it's kind of hard to see, but there's some diffuse nebulosity in there, kind of a light gray smudge. That is the remnants of Comet Atlas. Like I said, Comet Atlas has broken apart, so there's not much to see. It's about 74 million miles away from the Earth right now, and it's getting really low, so we're not in a good position in the sky to glimpse the comet anymore as it gets lower, but it is visible there in the center of our little square, so you can actually see that there. So that is the remnants of Comet Atlas, and that was actually the last comet found in 2019. So that is C 2019 Y4 Atlas, and what remains of it. So sorry, right there in the middle. I forgot to switch that on, but right in the center there, there's a very light gray that is the comet that we're actually referring to there. But let me turn that off. So obviously there's not a lot to catch on that comet, but we have a whole nother comet in the sky that is actually brightening, and it's pretty exciting. This is Comet C 2017 T2 Pan-STARRS is this one. So we're going to send the telescope up there. It's in a lot better position to catch tonight. And let's see, get our telescope tab there. T2, see if it finds it. There we go. And we're going to send our telescope over there. Not too far from where we're at, but again, this is C 2017 T2 Pan-STARRS is this comet. I tested the scope out on this last night. It is fairly bright and very easy to see, so it won't take much for us to catch it this evening. But we'll get that up here. We're doing 10-second exposures right now on our targets, so it's gonna capture it pretty easily here. So it should be right in the center roughly. There it is, right there. So let me pop up mine, see if we can try the crosshairs this evening. And dim this down right in here. I don't like the way that's working. Let's do the square. So turn the square on. Get down here a little bit. There. Right there. That is Comet C 2017 T2 Pan-STARRS, currently at a distance of 167 million miles away from the Earth. And that is something that should be brightening up in the nighttime sky over the next couple weeks. It does have a little bit of a tail on it too, so it'll be interesting to see this evolve, and hopefully it becomes easier to see as things move on there. So that is Comet C 2017 T2 Pan-STARRS. Current distance 167 million miles away from the Earth. And this is currently shining at would be 8.4 magnitude. The limiting magnitude for the human eye in a dark sky is 7. So this would be something that you will need a telescope for. It is not naked eye visible yet. We'll see where that goes in the future. But we'll be definitely keeping an eye out on it. And if it does brighten, we'll definitely check about that. Pamela, Comet Swan. So Comet Swan is a comet that a lot of people are asking about right now. And in particular, this is something that's visible in the southern hemisphere right now. It actually is visible in the northern hemisphere, but it is very, very low. And the comet we're talking about is C 2020 F8. Swan is its full designation. This is very low in the eastern horizon, just before dawn. So it's going to be a difficult thing to catch visually. So don't really plan to catch any of that. The guys down in the southern hemisphere really scored yet another one for them, and lucky dogs. So yeah, don't put too much on seeing Comet Swan if you're in the northern hemisphere, unless you've got wake up really early and you know where to look just before dawn. So that would be Comet Swan. But what we're looking at right now, if you're just joining us, this is Comet C 2017 T as in Tom 2 Pan-STARRS, and this is a distance of 167 million miles away. Alex, this is Comet Pan-STARRS C 2017 T2 is the name of that comet that we're sitting on right now. All right, so those are really the only solar system objects that we're going to be doing tonight, because again, tonight's all about galaxies. So we're going to start taking a jump off the deep end here. I will say we do have a special thing I'm going to try to do tonight. So what's really neat about the particular telescope mount that we are using, the software bisque mounts, these are very accurate mounts. And when aligned correctly, they're actually designed to track satellites. And tonight we have a really nice flyby of the solar system. I'm sorry, not the solar system, the space station, International Space Station. And that's happening in about 10 minutes. And we have the mount actually all programmed to where we'll hopefully be able to track it. And we're going to try to see what kind of pictures of the space station we can actually get. So I've never done this before on a live scenario. So we're going to give it a go, and we're going to see how it looks, and maybe we'll catch some solar panels and see some detail on there. So that's about 10 minutes from now. And as you can see, all these little satellites right here, all these are tiny little satellites that are loaded in the software. It's not hooking up right, but we are waiting for the space station to rise over in the southwest, right over there somewhere, but we'll catch that here in a minute. So hopefully in about 10 minutes we'll be able to get the space station and the telescope. Again, never done this before on a setting like this, so we're gonna kind of shoot from the belt and see what happens. All right. So let's get started with the actual galaxies real quick. Our first one is actually really quite popular. It's very easy to see, even from a light polluted location. Get a drink here. It is down in the southern part of the sky, and it's a fun little galaxy. It's a great little galaxy to actually view, and you don't need a whole lot of effort to see something like this. So let me get the camera turned on here, switch back over. So this particular galaxy that we're on right now, this is our first galaxy of the evening, and this one is known as M104 or Messier, which is what the M stands for, 104, also known as the Sombrero Galaxy. And I'm sure you can use your imagination to kind of figure out why we call it the Sombrero. It looks like a sombrero hat. So the Sombrero Galaxy is an edge-on spiral. So you can see this dark dust lane right along the edge there, and then its center core right in the center there. This galaxy is about 28 million light years away from the Earth, and about 130,000 light years edge to edge for that galaxy. Now the dark ring is a dust band, and that is actually cooler hydrogen gas in there. That's what it's composed of, and this is a star forming region within that galaxy. So there are regions inside that dark dust ring there where the gas is condensing down, making new stars deep in there. This is in the constellation of Virgo. We're going to be spending a lot of time in that constellation this evening. But M104, or the Sombrero Galaxy, 28 million light years away. So the light you're seeing right now from this image left that galaxy 28 million years ago. It's just now getting here. M104 was originally discovered in 1767 by Pierre Machon, which was actually Charles Messier's assistant. But this was not officially added to the Messier catalog until 1921 later on. Another cool thing about this is in 1912, M104 was the first galaxy to have the redshift observed. And what that means is they were able to use spectra to actually see which way the galaxy is moving and how fast. This was done right here, at least for me, in the home state, Arizona, at Lowell Observatory by Vesto Slifer, an astronomer up there. And it was documented that the galaxy was retreating at a speed of about 683 miles per second from us. This right there supported that the universe was expanding, and that also supported the Big Bang theory. Slifer also observed the rotation of the galaxy through spectral observations and became the first galaxy to have its rotation observed. So this is the Sombrero Galaxy in the constellation of Virgo. You can see this in a 6-inch telescope from decent skies. You can usually catch this in your backyard if you're not in a horrible light polluted location, but it is fairly easy to catch in darker locations as long as you have a nice clear southern horizon to catch that. So that is M104, the Sombrero Galaxy. And that's it for this galaxy. If I'm going too fast, if there's something you want to know, just let me know. We're going to see where we're at real quick. We're actually going to skip not far over. Let's see if I can get the telescope to just jog right over here. Whoop, there we go. So not far from M104, at least from our perspective. In reality, it's nowhere near the galaxy we were looking at. But the next target that we're looking at is kind of a fun one. And this particular one right here in the middle, let me pop up my little square once again and shift that over. So right there, that triangle of stars, you'll notice that there's an inverted triangle of stars inside of it. Now this is a fun little cluster, and this is called the Stargate cluster. Stargate is also in the constellation of Corvus. Even though it's very close to M104, which is technically in Virgo, they're right across the border from one another essentially. Stargate is known as a type of object that's known as an asterism, which is basically a connect the dots, if you will. Not quite to the extent of a constellation, but it makes up a fun little picture. So this is called the Stargate star cluster. It's got 3 stars to make up one triangle, and then in the middle it's got 3 other stars. That's the Stargate star cluster. The stars in this cluster range from 285 light years in distance to 486 light years. So they are quite a distance from one another. So something fun to see. You don't need a very big telescope to catch this. You can do it in a 4-inch telescope. It's a fun outreach target if you're ever out there sharing the night sky with anyone. But larger telescopes will help resolve some of the fainter stars in that cluster, because some of these small ones in the center here can be a little difficult to grab moving on smaller optics. So I would say about a 4-inch telescope. If you've got a 6 or 8-inch or bigger, it really helps pop out all 6 companions of the Stargate star cluster. So again, this is Stargate in the constellation of Corvus, ranging in distance from 285 light years to 486 light years. So it's a fun one. Try it out with your friends. If you've got anybody over, it's a cool little target to mess around with. All right, we're getting pretty close to the ISS Transit. So we're going to switch over to that and see if I can get the telescope ready to go on this. So like I said, I've never done this one before, so we're going to see if we can get a hold of it. It's just broken the horizon from our perspective. So let's see if we can get over there and track it. So bear with me as I get the telescope over there. I'm going to start low, and then we're going to kind of rake up as it gets higher and higher into the sky. And we'll see what we can see on it. This is going to be relatively interesting. This is an object that's moving 17,500 miles an hour, and we're going to attempt to follow it. So we'll see what can happen. All right, so it's still fairly low, but we are gonna wait for this thing to rise up into the sky and see if we can get the mount to track this real quick. And tracking satellites is an interesting observation. There's actually a lot of professional observatories, military stuff like that, that track satellites. It's called space situational awareness, is what that process is called. There's a lot of observatories that are constantly doing that, and it's really kind of an interesting field to study at that point. I think we jumped on this a little early. Let me just double check where we're at with it. All right, so there's our alarm. It should be coming up here shortly. So let's see. We can get our camera going here. Like I said, this is never done this before, so we're gonna see what we can get on it. It might still be a little low. Yeah, still low. So let's see if we can find this real quick. Turn our camera off here. And Jeff, the telescope we're working with tonight is based in Phoenix, Arizona right now. So that's where we're based at the moment. So let's see if we can get on target here. So tracking satellites is kind of a process. It's always an interesting one to do. There's a lot going on that has to make that happen. A lot of the mount information that is doing stuff right now, we pull all of that information off the internet and get the orbital velocities and stuff like that. So it's definitely an interesting process. It's kind of a fun one to do if you can. So again, just trying to get all of that plugged in there and see what we can do on that. Let's see. So like I said, this is the first time I've done any of the satellite stuff. Let's see if we can slew and catch this one. All right, so let's see how this one does it. So we're sitting on another satellite right now. This one's pretty small and dim, but the mount is trying to track it. But it's not the one that we want. So the space station should be a lot different than that. So let me see if I can stop this. We will get back to galaxies here in a second. This was just kind of a unique thing that we might have been able to do tonight. So I'm not sure why it's not doing what I need it to, but let's see. See if we can get some of this information pulled down real quick. Well, I'm not sure we're going to be able to get this one tonight. I was hoping we were, but like I said, this is kind of a new thing. I haven't been able to really experiment too much with it because it's all about timing. And unfortunately, for whatever was going on tonight, it wasn't wanting to listen to me. So thanks for letting me try that out. And I'll try to see if next time we can get something pulled down, and maybe we can get something next time. So I appreciate you letting me mess around with that live. I was hoping we could get it, but let's see. It's probably well gone right now. Timing's a little off. That's why our timing was off. Okay, now I know why our issue is there, because the timing on my clock is not correct. So it's saying it's there. Okay, anyway, enough with that. We tried, so maybe next time I will mess around with that, but I'll have to get this all figured out and see why everything's... The clock on the telescope mount down here is actually off. And I don't know if we can fix it real quick. So let me see if I can fix it without messing anything up. Okay, let's try this again. Find it. Okay, we actually have it now. So let's see if we can go catch it. It might be too late, but learning curves. But the mount's racing over to catch it right now. We're gonna see if we can catch it. But it all we need is one little shot. Okay, let's get the camera going real quick. It might be too low. Let's see. Yeah, we might have lost it in the tree, but oh, we gave it a shot. So anyway, tracking satellites, you're basically shooting a moving target, so it's difficult. But we gave it a go. So thanks for letting me mess around with that. We'll hopefully another time we'll give that another go. If you actually want to see one real quick, let's see if we can just go, just so I can show you guys how this stuff works. Let's see if we can just slew over to this one real quick. And then we'll get back to our regular broadcast stuff. But and then we'll get back to what we were supposed to do tonight. But yeah, trying to track the satellite on the fly is not something it's generally easy to do. Let's see if we can get... I just want to show you guys how this works real quick. So it's going to grab this satellite real quick. I'm not sure what it is, but we'll just let it do its thing. See what we can get out of it. So probably need to go a little longer. Let's do 1 second real quick. Okay. Don't worry, I've got a bunch of other stuff coming up for you guys real quick. So anyway, we'll come back to this in a later date. We'll practice and come back and try doing satellites another time. But anyway, thanks for letting me entertain that real quick. So to make up for all the lost time, there is a special thing going on right now in one of our galaxies that we're going to be checking out tonight. And we're going to go off and find that galaxy and leave the satellites to themselves and get back to what we're supposed to be doing tonight. So All right. So we are finally on our target. And let me get rid of what we're locked on. Okay. So let's get to the camera. Switch over here. Okay. So now back to the normal stuff that we're doing tonight. So this galaxy has been getting a lot of hype lately, and it's going to come up here in just a second. Wait for this to pop up. And there's a satellite right there. There you go. Nice little streak satellite. So this is M61. M61 has been in the news lately because it has a supernova in it. And right here, I believe, is the star that we're looking on. Let me stop this. Fix something here. It's back in the so we're gonna, let's see. Okay. Get back over to M61 real quick. Okay, sorry about that. Had to get unlocked from a satellite. So let's get back into our images. Okay, got derailed a little bit. So we should be back on M61 right now. Okay, there we go. Back on M61. So M61 is a face-on spiral galaxy, and you can start to see, actually we can blow this up a little bit. There we go. Is a face-on spiral galaxy. So you can see the arms here. It looks like it's a barred spiral as well a little bit. This is 65 million light years away from the Earth and 80,000 light years in diameter. And right in here is the supernova that has just been not fairly recently discovered. The supernova was actually discovered, let's see, fairly recently. May 6th is when the supernova on this was discovered, which is actually interesting because the official discovery date was May 5th, 1779, by Berenices. And this was originally thought to be a comet. And Charles Messier actually observed this on the same night, thinking it was the comet, but it wasn't. And it wasn't until a couple weeks or a couple days later that he discovered the mix-up that he had and went back and documented that as the comet, as the actual galaxy. And the galaxy supernova right here is this guy. So this guy right here, that is the supernova. Yep, looking at charts. This is the supernova right here. So what's really cool about this particular one is that this galaxy has had 6 supernovas observed in it from 1926 to 2008. So supernova 2020 JFO, which is the name of this one, is the 7th supernova to be observed in this galaxy since its discovery. And what was interesting about it is that it is almost 241 years to the day that it was discovered, off by 1 day. And that is M61, the face-on spiral right there. So pretty neat. This is also in the Virgo Cluster, and it can easily be seen in telescopes about 8 or 10 inches in aperture right there. And if you had a larger telescope, it would really give you more punch and more resolution, but something to check out. So again, that is M61. We're streaking a little bit here. So, go. we're in a weird part of the sky right now too. We're right on the Meridian. Where the Meridian right here is this imaginary line. Let me get rid of my little box here. There we go. The Meridian right here is an imaginary line. So everything rises in the east until it gets to the Meridian, and then everything past the Meridian sets in the west. So the Meridian is that middle part of the sky there. So we're going to keep our position here, and we're actually going to move not too far away from where we currently are on M61. And we're going to go just a little bit north, and we're going to check out another popular galaxy not too far away. And let's see, pop this in there real quick. So this galaxy, we're actually in the heart of the Virgo Cluster now. And the Virgo Cluster is a massive cluster of galaxies in the constellation Virgo. And this particular one is called Virgo A, or M87. And this is the largest galaxy within the Virgo Cluster. And it was originally, I'm not sure what my tracking issues here are, but it's bugging me. So let's see here. So we're on M87, fighting my mount a little bit. There's a little bit of a breeze out there as well that could be shaking things and causing it to streak. So, okay, let's see if that helps us a little bit. So we're going to get a little bit better positioned here real quick. Get it centered more. And then we'll be good to go. There we go. All right, flip back to our camera here. And see if this helps out the tracking a little bit. So the Virgo Cluster is a large cluster of galaxies in the constellation of Virgo. Right in the middle of that, however, is M87, or Messier 87. It is 55 million light years away from the Earth, 113,000 light years in diameter. That's much better. There we go. So M87 is actually right here in the center. Right there is M87. All the little fuzzballs that you see around it, fuzzballs is a highly technical term, of course, are other galaxies within the Virgo Cluster. And the Virgo Cluster, like I said, houses hundreds and hundreds of galaxies, but right at its center, of course, we have M87. And this was originally discovered by Charles Messier in 1781. And this is an elliptical galaxy, and it's very spherical, which allows it to have a lot more mass because it's completely spherical. And it has, therefore, it's got a lot more room to pack stuff in. Now, the Milky Way has roughly 1.5 trillion solar masses. So 1.5 trillion times the mass of the sun is what our Milky Way is roughly composed of. M87 is much larger. We're talking about 2 to 3 trillion solar masses, so almost double the mass of the sun. The mass of the Milky Way. Got too many numbers floating around. And allows it to have a lot more things going on inside of it. Now, the outer portions of M87 are actually distorted, and this is mainly due to the gravitational pull from other nearby galaxies in that Virgo cluster. Now, because it has so much mass within it, M87 has actually one of the largest collection of globular clusters of any known galaxy. Just to give you an idea, the Milky Way has about 150 to 200 globular clusters that form a halo around the core. M87 has nearly 12,000 globular clusters. And if you're not familiar with what a globular cluster is a dense ball of stars, like a bundle of stars, where several 100,000 stars are bundled together by gravity. And later in the evening here, I'm hoping we'll get to a couple targets where we'll be able to see what a globular cluster actually is. Now, M87 also has another feature about it that's relatively interesting. The core of M87 is very active with radio and X-ray emissions, as well as gamma rays. And when you have something like that going on, that generally tells us that there's a black hole at the center of the galaxy. And at the center of this particular galaxy, there is a concentrated region about 60 light years in diameter that has a massive spinning disk of gas. And in 2017, this was actually photographed, and at the heart, we were able to discover a black hole. And this image obviously went viral when it was first published last year in 2019, where we got our very first image of a black hole, and that is where it resides, is in M87. Now, what's interesting in there is black holes generally have jets of material that are shot out into space, and that material as enters and then flown out. M87 has a visible jet, and that's actually why we're on this right now, because if you look very, very closely, right here, there's a little white line that you can kind of see. That is the jet facing us. Not directly, but it is facing us. So if you look close there, you can actually see one of the jets coming out of the center of M87. This jet right there is about 5,000 light years long, just to give you an idea. But you'll notice that's kind of spherical, and then a little white line right there. And that is one of the large jets that are jetting out of the black hole in the center of M87. In a very large telescope with very good skies, you can visually see that jet. So it's kind of a good challenge target. And you're going to need a big telescope, and probably something like a 20-inch or larger, nice high magnification. So you're definitely going to need something. It's coming out a lot more right now. So, excuse me. Lots of talking today. So that is M87, and there are some amazing pictures of M87 online. Let me see if I can pull something up for you guys here real quick, and get something cool there, and be kind of cool. Let's see. Bear with me just a second. Get something nifty. All right, so this is going to be an image from NASA, of course, and let me scoot this over here. This is M87 from NASA, and you can see the jet right there, and we are basically looking at this right here and the jet right there. So we just need to kind of rotate this 90 degrees, and it would match up. But as you can see, there's the jet of material coming out of the core of M87, and the fact that we can see this from a light polluted sky with a 6-inch telescope with amateur equipment, that right there is the jet. So pretty neat. That is 55 million light years away from the Earth. So when the light left here, dinosaurs still basically roamed the Earth for the most part. So that's M87 and its black hole jet. So we're going to continue on our galaxy tour, and let me stop the exposures here real quick. Flip over to our next target. This one is almost straight up. This is a really cool galaxy to see. I think it's probably one of my favorites. And it's easy to see in even a small telescope, like 6-inch, basically what you'd be able to get nowadays as a beginner telescope. Let me get my little square out of the way. This is NGC 4631, also known as the Whale Galaxy. And the funny thing is it looks very similar to a whale. This is 30 million light years away from the Earth, 100,000 light years in diameter. It is a edge-on spiral. So, like we talked about earlier, we are looking along the galactic plane, right on the edge there. And this one is distorted a little bit because it actually has a little companion galaxy up here. NGC 4627 is the little companion. And that, over time, has distorted the galaxy a little bit. Let me check our tracking here real quick. We're in a weird part of the sky that the telescopes at times do not like to behave in. So let's get back on that. Getting it back onto our image now. Okay, back on our whale galaxy. So this is, like I said, it's an edge-on galaxy. It's actually intermingled with this little fuzzball, this galaxy right here, NGC 4627, and has distorted some of the galaxy edge over here. And longer exposures, you can start to see some of the, how it doesn't look quite as smooth as in other edge-on spiral galaxies. This galaxy was originally discovered by William Herschel in 1787, and when he first discovered it, he called it the Herring Galaxy after the herring fish because it resembled the fish. So over time, it's gotten the name Whale Galaxy. This has hosted so many supernovas in it that it actually has generated a super wind of ionized hydrogen gas blowing out away from the plane of the galaxy, and has created quite a solar wind around the region as well. So that is the Whale Galaxy, NGC 4631. You can pick this up in an 8-inch telescope. Darker skies will definitely help pop it out. If you get a chance to actually look at it in a large telescope, it's quite a view, so I would highly recommend it if you can. It's a pretty cool galaxy to see. And not far from that, and you can normally get them in the same field of view. Excuse me. Let's see. I don't think we'll be able to do tonight. We're running a slightly more narrow field of view on tonight's telescope than our normal rig. But right next door to this is NGC 4656, also known as the Hockey Stick Galaxy. Also, just to go back on this, these are both in the constellation of Canis Venactices. So there's our hockey stick, and I don't know why our mount's not happy with all this right now. Sorry for going back and forth. It's giving me some trouble. Probably because we're shooting in a spot it doesn't like. So, we're back on the Hockey Stick Galaxy, NGC 4656, 17 million light years away, 32,000 light years in diameter. It is another edge-on spiral. You can kind of see the hockey stick looking thing in there. A lot of times you can get the Whale Galaxy, the one we were just on, which is NGC 4631, and this galaxy in the same field of view. It's pretty neat to see the two in there. They're kind of a cool companion set, even though they have nothing to do with each other in reality. Like, the Whale Galaxy is almost twice the distance of the hockey stick. So this is NGC 4656, and it's got that hook over here that gives it that hockey stick appearance, and that has come from disturbances with coming too close to other galaxies. So this is a fun one that you can go check. It actually extends pretty far out as well. There's kind of a star tail that comes off the edge of that galaxy, so it's a pretty neat one to see in about a 10 or 12-inch telescope. And if you have access to dark skies, things get really cool because you're getting more of that detail there. So again, this is NGC 4656, the hockey stick galaxy. Now the next one coming up is a fan favorite. It is a must if you ever get a chance to see it in a telescope. It's very, very cool to check out. This is in the constellation of Canis Venactices, and this is known as the Needle Galaxy. And it is quite an image in a large telescope. It looks very much like a UFO. And let me see if we can really pop this out. We're going to go a little longer on the exposure just to see if we can pull some stuff out. But this is known as NGC 4565, or the Needle Galaxy. And it is an edge-on spiral, very similar to what we saw earlier with M104. And but this is a much larger galaxy. It's a bit further away at 93 million miles away from the Earth, 192,000 light years in diameter. So it is big galaxy, and has a very large center dust band. There it is. NGC 4565 is the name of this galaxy, and you can see some background galaxies as well. This is an awesome galaxy in a telescope. If you ever have a chance to get to see it, you can see it in a 6-inch telescope, but if you ever get a chance to get like a 20 or a 25-inch telescope on this thing, it's unbelievable. You get molting details inside of the dust band there, and it really does start to look like a UFO. This was originally discovered by William Herschel in 1785, and it does have a large collection of globular clusters. About 240 globular clusters are in this galaxy. So it's really, really quite something to behold. So again, this is a large edge-on galaxy, 192,000 light years in diameter, which is huge. Let me just reference this really quick. Our Milky Way is about 105,000 light years in diameter, so this is almost twice the diameter. Hair Clip, that's a great name for this galaxy, but so this is NGC 4565, or the Needle Galaxy, in Canis Venactices. It is a must-see galaxy if you ever have the chance. If you're ever up in a large observatory, definitely check it out. And if you're ever at a star party, ask someone with a big telescope to throw it on it, because it would be very, very cool to see it. It doesn't look too different from what we're seeing right now, and you can kind of see some little faint fuzzies in the background if you can as well. So we're going to continue on to our next galaxy. Just a wide variety of galaxies tonight. We've got a couple more left. If there's something you want to see and I didn't get to it, let me know. But we've got quite a list tonight. Starting with these next set, we're heading back to the Virgo Cluster. And this particular part of the Virgo Cluster, this is a set of galaxies that are really, really neat, and are best known as the Eyes is the name of these galaxies, NGC 4435 and NGC 4438. So let's give this a shot and see how it looks. I haven't done this one yet, so this will be new for all of us. Let me get a drink here so I can keep talking. There we go. So these are fairly faint, and there's some really cool faint detail in here. So we've upped the exposure to 30-second exposures, just so we can pull all that detail out. We want to get as much of it out as possible. Normally when I'm shooting, not doing these events, when I'm actually shooting photography of this stuff, astrophotography, we're doing 5-10 minute exposures, something long. So here's the Eyes. These two right here, and that's, let me can actually pop my little square up if you guys, I'm sure you all are capable of seeing it, but right there, those are the eyes, are the name of these galaxies, and they actually have these really elegant tendrils in between them, but it's very difficult to catch them in such short exposures. These are 37 million light years away from the Earth and about 98,000 light years in diameter. And these are an interacting pair of galaxies. And at the moment, they're about 100,000 light years apart from one another, but from observation models studying the physics of these galaxies, they were 16,000 light years apart. So they got really, really close to each other. And these two galaxies actually belong to a chain of galaxies. And my buddy Jim O'Connor, who's actually chatting in there, used to do the whole tour of this chain. It's called Markarian's chain in the Virgo Cluster, and it's a collection of galaxies that makes a really cool, elegant chain. And you can actually skip from right down the chain of different galaxies. It's really interesting to see in, you know, a 12-inch or bigger telescope. So this is the eyes. Let's see if I can adjust this real quick. No, that's not. You can kind of see right here one of those little elegant tendrils that are starting to come out right in here. So that's what we're talking about. We need a longer exposure to do it than what we're doing right now and have the telescope sit out there and check it out. But this is the eyes, NGC 4435 and 4438. And it received the nickname the eyes from a 19th century observer called L.S. Copeland, is how it got the name of, or how it was able to get the name of these galaxies. So that is the eyes in the Markarian's chain. Now the next target is, actually it's one of my favorites. It's not much to look at, it's the thought of what you're looking at. This is the furthest target we will probably do. It's the furthest target we're definitely doing tonight, but will be one of the furthest targets that you would actually observe even through a telescope. So let's get the camera here, jump start that. We don't need to do as long of an exposure though, because it's going to look a lot like a star. But we'll get the image to come up here. All right, so this looks a lot. Let me get my little square out of here. There we go. This looks a lot like a star field, and you would be right because that's exactly what it is. It's a star field. But we're actually looking at a particular very, very distant object in this field. And this particular one is right down here. I can drag this around. All right. So we're looking at this particular triangle of stars is what we are looking at here. And one of these stars is not a star. One of these things is not like the other. So one of these stars right here, actually pop this down real quick, just so we know exactly what we're talking about. There's not that guy right there. That is 3C273. This is a quasar. This is the furthest object that we will be observing tonight at a distance of 2.5 billion with a B light years. So the light we're seeing right now left there 2.5 billion years ago. Quasar is an active galaxy nucleus, and what that actually means is that there is a black hole in the center of this distant galaxy actively feeding on material. And when that happens, there's an immense amount of heat that builds up and it causes it to glow very, very bright to where it actually overshadows the black hole itself. and all you see is the light emitted from that heat. And that's exactly what we're seeing right there, is a quasar, 3C273, 2.5 billion light years away from the Earth. It's the first quasar to be ID'd by a 1960s astronomer Alan Sandage. And quasars are the most distant objects that we can see in the nighttime sky, and there's a handful of them, and there are several billion light years out there. This is one of the closest to us at 2.5 billion light years away. This can be seen in a 10-inch telescope, and it's a little bit of a challenge, but it's a fun one to do just because that's what I like to call a concept object. There's no real frills about it. It looks just like a star, and that's it. But it's the concept of what you're looking at. That's what I like about these. So again, that's 3C273 in the constellation Virgo, and that is a quasar. So something fun to show your friends when you have some time. But it is going to be a cool object if you ever get out to some dark skies and you really want to impress your friends and you're ready to jump off the deep end. It does not get much deeper than that. Actually, it does, but that's an easy one to get in a 10-inch telescope. All right, so let's continue on down the list. So the next one up here is another spiral galaxy. We are on this particular galaxy is known as M64, or the Black Eye Galaxy. And once the image comes up on the screen, you'll be able to see why it gets its weird name. This is in Coma, Berenices. It is 17 million light years away, 44,000 light years in diameter. And it was originally discovered by Elert Piggott in 1779. Now, as you can see right here, it looks like a black eye. Kind of weird, huh? This is a dark dust region just above the center core here. And what's interesting about this galaxy is from observations, the outer portions of the galaxy, the outer gas in the galaxy, is actually spinning the opposite direction from the center portion of the galaxy. So it's kind of an interesting phenomenon going on there. So, all right, we're just getting the... ever since we did the satellite, the tracking's been a little bit weird tonight. So, just getting things a little tighter there so we can get a nice, cool picture of it. So let's get over here. It's doing its thing real quick. It's going to pop that in the center. There we go. It's going to fix its pointing. And whoop, all done. Now we can flip back into our camera settings. So again, this is the Black Eye Galaxy, M64. Coma Berenices is the constellation. 17 million light years away from the Earth. 44,000 light years in diameter. And it gets its name from having that dark dust portion just over the core. So it looks like a black eye. Originally discovered in 1779 by Elert Piggott. And interesting thing about M64 is that the outer material on the very edge here is spinning the opposite direction of the core of the galaxy. And from observations, they believe that this was happened from M64 coming in contact with one of its satellite galaxies and pulling it in and having it kind of pull that material apart. And that's where they're thinking why the outer regions are spinning differently. But this is the Black Eye Galaxy. You can kind of see that dark dust material in there, and that's where it gets its name, Black Eye Galaxy. The next one is actually interesting. They're all interesting, of course, but let's see. We're not going too far from where we're at right now. And if you're looking on the screen, you might be wondering what all those dots are. Those are galaxies. and this is the Coma Cluster. And the Coma Cluster is a collection of thousands of galaxies. And what'll be fun here is when we get the images going up on the screen here in a second, you're going to notice that as the camera starts to expose more and more and more, there's just going to be more faint fuzzies coming out. Faint fuzzies, by the way, when you're here on Starstream, is a highly technical term. So have fun with that. All right, so we are in Coma. Berenices is the constellation. And right now we're in the Coma cluster. And it's going to come up right here. Boop. So if you look close, you'll look and see all these little things in there. They look like out of focus stars. Those are all galaxies. And the longer the camera is going to sit here, actually here, I'll do you guys one good. We'll talk about this a little bit. We're going to do a really long exposure, at least for a Starstream episode. I'll leave this up. We're going to do a 1 minute exposure. So the camera is going to be open for 1 minute. So the image that you see right here, that is the Coma cluster. The cluster has over about 10,000 galaxies inside of it, and it's roughly 320 million light years away from the Earth and 20 million light years across. This is a cluster of galaxies and is also known as the realm of the galaxies. This particular cluster actually covers 9 times the area of the field than the full moon does in the night sky. So this is a big chunk of the night sky in a whole. And this cluster is actually where the theory of dark matter is rooted. This was originally composed by astronomer Fritz Zwicky. He was a Swedish astronomer. He observed and estimated the cluster's overall mass. So as you can see right here, the exposure just came up. You can see all these little fuzz balls in there. All those are galaxies, thousands and thousands. And this is only a 6-inch amateur telescope. If we had a pro telescope larger and we set it there for a long time, it would pull all kinds of stuff out. But back to the little fact here. Fritz Zwicky, the astronomer that studied this cluster, he observed and estimated the cluster's overall mass, which determined the total gravity of the cluster. And calculations showed that the mass exceeded what the visual observations were documenting. And this is where the idea of dark matter came into play. And this is all from observations done on this cluster, or the Coma cluster. And it's a very, very cool section of the sky to point a telescope at. As you can see, as things are getting more and more exposure time on them, more and more stuff is coming out in the field. So it's very, very cool, very densely populated area of the sky when it comes to galaxies. So that is the Coma cluster. All right, we're coming up to our last handful of objects, and the next one is actually not going to be a galaxy at all, just to give us a little bit of change up here, because we've been talking a lot about galaxies tonight, but there's a lot of other cool things up in the nighttime sky, and I like to give a little bit of variety so you can see a couple things. Now, this particular target that's coming up is very easy to see. You can see it in a pair of binoculars. A 3-inch telescope will look very cool, and as you get bigger, it'll start to resolve further. So this is in the constellation of Canis Venactices, and it's a star cluster. And now you've heard us talking about globular clusters throughout the evening, and this is one of those globular clusters located here in the Milky Way. And a globular cluster is a dense ball of stars held together by gravity, and this particular one is known as M3. And M3 has about 500,000 stars. Let's get the exposure down. We do not need a 1 minute exposure for this. So we'll dip that down a little bit. M3 was discovered by Charles Messier in 1764, but it was not resolved into a cluster officially until William Herschel observed it in 1784. A little bit more aperture helped resolve more of that detail. So here's M3 for you guys once the image pops up here. That's my camera. There we go. M3. It's actually a beautiful cluster to see in a telescope. You don't need a lot of aperture to do it. You can do this with, like I said, binoculars, but if you can get like a 3-inch telescope or even bigger, you start to get more and more detail. So this is 33,000 light years away from the Earth. It's 175 light years across, and it's not like in... Hold on, guys. Get this set. There we go. Messing with me tonight. So M3, 33,000 light years away, 175 light years in diameter. You've probably heard me talking about light years a lot tonight. If you're not familiar with light years, 1 light year is about 6 trillion miles. So a lot of space. This has about 500,000 stars in it, so 500,000 stars. It's one of the larger clusters, I guess you could say, in the Milky Way. Now, M3 is on an inclined orbit in the Milky Way galaxy. So what that means is it can go nearly 50,000 light years above and below the galactic plane of the galaxy. Right now it's situated about 33,000 light years above the galactic plane. And they estimate the age of this by observing the stars. There's a lot of older orange stars in this cluster. This is aged at about 8 billion years old. So if you're into vintage, there you go. So this is M3 or Messier 3 in the constellation of Canis Venactices. This is a great object to actually go out in your backyard and check out with a small telescope. No reason you can't get a nice view of this cluster with very, very basic, minimal equipment. So give that one a try. It's a fun one to do from home. So again, this is M3. Canis Venactices is the constellation, 33,000 light years away from the Earth, and 175 light years in diameter. And it's quite a view in a telescope of around 10-inch or larger, especially in a dark sky. All right, so there are 2 targets at the end of this list, and these are very challenging from this particular location. Even though we're based in Arizona, I don't know if we can hit them right now. We're going to give it a try and see what we can do. And these are going to be really low in the light pollution of Phoenix, so let's hope it's high enough to get. All right. So this is a fun one, and a lot of people in the northern hemisphere really try to get this target, and the reason why you don't see it too much is because it is low. Let the camera do its thing. Jeff, we're running 150 millimeter, so 6-inch apo refractor. So right here in the center, it's a little off center because we are low. We're in a really this particular galaxy is. I've jumped ahead too much. This is NGC 5139, or I'm sorry, too many. NGC 5128. This is Centaurus A. 12 million light years away from the Earth, 90,000 light years in diameter. This is a very, very cool galaxy, but it's very low to the horizon. And actually, from my location where the telescope is right now, the highest this thing gets is 13 degrees off the ground. which is very, very low. We're down in the muck of the sky. And the fact that we can see this, I have a very small window where I can actually catch this object. So we're very, very low in the sky right now. If you were in the southern hemisphere, this would be almost straight up. That's the way to see it. So this was discovered in 1892 by James Dunlop. And NGC 5128 is a merger of two galaxies. And that's why you kind of see this dark banding right in the center there, and that hazy center right in the center. The center portion contains a lot of highly evolved red stars, where the dust lane has over 100 star-forming regions called star, and this makes it a starburst galaxy because of all of that in there. This has a supermassive black hole in the center of it. It has a lot of radio and X-rays being emitted from the galaxy, which tells that there is a black hole down in there. And this is very, very difficult to see from the northern hemisphere. If you were in Texas or something, kind of South Texas, this is a lot easier to see. Here in Arizona, we just clear it here. So it was kind of I was really hoping we could get it tonight. So there's a very small window from where the telescope is located at the moment that we can get it. All right. So that is the last galaxy on the list. But because we are way down in the southern portion of the sky, we have one more object to get a hold of. And it's not far from this one. And this one's going to be even more of a challenge than Centaurus A, this galaxy right here. And we're going to give it a go and see if we can get it. A lot of my friends who are on here are going to know exactly what we're pitching for right now. This is the Holy Grail globular cluster in the Milky Way. And it actually cleared my horizon. And it is really low right now. So that's why the telescope's pointing in a weird position. Let me get all the tracking where we want it to be. It's going to be a little off center. The highest that this thing gets is only 8 degrees off the horizon for my location. This is, like I said, the largest globular cluster in the Milky Way. This is NGC 5139 Omega Centauri. And this is kind of a holy grail target for us here in the the northern hemisphere. It does not get very far above the horizon, so it's a very, very difficult target unless you're down in the southern parts of the U.S., like South Texas or Florida or Hawaii. Is actually a really good place to see it. And then obviously the closer you get to the equator, moving into the southern hemisphere, it's less of a challenge because it's right overhead in the southern hemisphere. So Omega Centauri is in the constellation of Centaurus, 17,000 light years away from the Earth, 271 light years across. This thing is freaking huge. It would take you 271 years to cross this cluster going the speed of light. This has over 1 million stars inside of it. And it's actually thought that this is the leftover nucleus of a dwarf galaxy that may have merged with the Milky Way. The cluster was actually originally documented by Greek philosopher Ptolemy in the mid-2nd century AD. But it was not until the 1830s when John Herschel documented it as an actual globular cluster when you're able to actually use a telescope. This is easily naked eye visible if you're in those southern latitudes. Like I've observed this from Texas, and it's naked eye visible, and easy from there. If you're in Hawaii, very easy. And then of course if you get down to Australia and New Zealand, this thing is right overhead, so it It's plain as day down there. So if you ever get a chance to go down there, definitely check it out. So this is Omega Centauri, the largest globular cluster in the Milky Way, several million stars, and NGC 5139 is the name, its catalog number. So that pretty much wraps up the observing list. We were able to hit everything except the International Space Station. We will try again on that one in the future. But I really kind of appreciate you guys letting me screw around with the satellite tracking stuff tonight. We will get the ISS shot. We're fully equipped to do it. Just need to mess with it a little bit more. But thanks for joining me tonight. It's actually been a lot of fun cruising through galaxies with you guys. If you ever want to join us again, you can go to focusastro.org and catch up on all the stuff that we're going to be doing. And I can get my information up here real quick. All right. So, yes, thanks for joining me this evening. If you ever want to see what we're doing, you can visit focusastro.org. Or you can subscribe to the YouTube channel. If you really like these star parties, I appreciate you being here. If you subscribe to the channel, then it knows when you're going to have future ones. We do this every Friday, weather permitting. The next one is actually coming up on, not next Friday, the Friday after that. That would be May 29th is actually the next star stream, and that one's going to be all about the moon. We're going to be zoomed in on the moon, checking out craters. So that'll be the next one. And then the one after that will be June 12th. And that's one where we dive into some more galaxies, and we start to check out some of the cool summertime stuff that's actually coming up at that point. So that's all coming up here soon. And but again, thanks for everyone checking in. This is kind of the only way we can continue to do outreach, even though we have not able to really be around big crowds. So make sure you tune in every other Friday for our Starstream webcast. And then when things go back to normal, you can also catch us out at one of our actual star parties where we get to look through the telescopes. But thank you all for joining me tonight, and have a great rest of your weekend, and stay safe and clear skies. Thank you very much.